notion that business applications exist, that's probably where they'll all collapse, right, in the agent era.
AI agents are domain-specific task experts.
Combining a UNet regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
The age of agentic AI is here for every organization.
As you can see that everybody says agents, 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 and agents gonna replace SaaS, agents gonna replace workforce, and agents gonna take over the world. But nobody is actually telling where should we use agents.
Everyone, today I wanted to discuss about really interesting technical report released by Anthropic, and it does have a key interesting points of like what is a agent and how to differentiate between a agent versus a workflow, and when should you actually use an agent. uh, because agents are very expensive. It's not cheap to run an AA agent or anything. So let's go over it. And he basically assigns something to an A agent and assume that A agent has access to a database access, code execution, and have access to any kind of LLMs. And finally, we get an output. This is a regular, like a pipeline which gets followed for any kind of an AI agent who has access to multiple tools and finally generates an output. For example, imagine that James Bond is an AI agent. As a AI agent, he must have like a different kinds of skills. Maybe he has like a martial arts, driving, he's good at shooting, and he has a knife mastery. Then imagine that the head of MIA basically ask James Bond to basically go to New York. But instead of just saying that go to New York, she specifically tells him to go to New York by flight 101 at 6 a.m. So basically, James Bond takes a flight which is at flight 101 at 6 a.m. to go to New York. And this is where in the James Bond actually following a predefined path which is given by the head of the MIA. So he's not following anything else. It's a predefined path which can be guessed before because it's given clearly in the instruction. And if something is like that, which is a predefined path where there is no changes or deviations itself, then it's called as a workflow. So Anthropic defined it as a workflow where you can actually know the predefined path an LLM agent can actually take in hand before is called as a workflow. So you don't actually need agents for the task which can be achieved by using workflows. We will try to see some examples later on in the slides, what are such kind of tasks, etc. But for the task which can be routed using predefined paths, we can use workflows instead of agents. That's the main point here. And now imagine in the second case where James Bond has been given a task to go to New York, but instead of that, they didn't specify the timing or the way of transport or mode of transportation, etc. So he can either go by flight, he can take a train, he can go by a car. He can actually go by car and then basically doesn't like it or car breaks down in the middle, he goes by a train. And this is called as an agent. Agent is completely dynamic. Agents can be used for open-ended problems when there is difficult or impossible to predict the required number of steps and where you cannot hard code a fixed path. So there is no predefined path and the path is completely dynamic. In such scenarios, you cannot premeditate any kind of a path or anything related to agent. In such case, it's basically you need to execute a thing called agents. That's how they differentiate agents versus workflows. The next in the current slide and next slides, we will basically see that they have given a couple of different interesting examples of LLM gets called in parallel, sequential, and output of one LLM is the input to another LLM, and so on, and when to actually use an agent itself. So the first example, basically, you can see that you have a three LLM calls, but you can see that all of them are actually sequential, means the output of one LLM is actually input of another LLM, and so on. And such kind of sequential task can be just written and followed by a instruction itself. You don't need a specifically bigger agent to do this thing. That's the first important step. And the second one is routing, which is that you might have like a three LLMs. One is good for like a classification of input into like 3 or 4 tasks, and the second might be very good at like summarization task, and third might be very good at answering question and a about your documents. And you might have llm which is a router. So for a given input it can decide which llm to call, and finally you get an output. So in such case scenarios also you don't need to really use agents, you can actually use just a regular workflow based routing methodology to achieve the final result itself. And it is useful for customer service inquiries where a customer service might ask inquiries regarding to billing or some kind of bugs and so on, and the llm can actually reroute them to the specific llm which is required. And this is the best way for routing uh, based LLM. And the final one is parallelization, where you have multiple LLMs which you need to call parallelly, and finally you have an aggregator and you have an output. And it is very good when you have a very big task and you wanted to split that bigger task into actually smaller tasks itself. And imagine a task where you have a like a big document and you wanted to write a summarization of the document but a section by section basis. Maybe the document has like an introduction, problem statement, and experiments, and finally conclusion. And if you want llm to write like 5 important points in each one of them, you can call actually llms in parallel and give each llm the required input. Maybe the first llm it might be introduction, the second llm it can be about problem formulation, and the final llm can be maybe conclusion or experiments. And finally you can aggregate all of them using another llm. So some things of a bigger task which can be broken down into smaller tasks but a predefined paths can also be achieved using workflow parallelism, and you don't need really an agents for this case too. And finally thing is that orchestrator workflows, where imagine a central conductor coordinating an ensemble of specialized AI workers. So it's pretty much very similar to the previous one, but just that a orchestrator actually handles all of them. So it's like the orchestrator is kind of a master, and the rest of the LLMs are like a students under that master, and the master basically controls all the LLMs itself. Like sometimes you might need to have one llm call before, and until you need to wait until that llm finishes the whole process, then you need to call another llm, and those all things can be handled by orchestrator itself. And using workflows you can actually build this kind of techniques of orchestrator. You don't really need to build an agent or anything which is more complex. And it is generally used for, if you have a bigger task you can actually subdivide them, and you have a bigger orchestrator which is like a really expert in all the sub students or subtasks itself. And it's ideal for complex coding projects requiring updates among multiple files. Like imagine in one file you update the code, but in another file you need to update the imports which you written in this code and so on. And this kind of orchestrator can actually do that. And the final one is the Evaluator-Optimizer. And this is pretty easier, where you have two LLMs, but the output of one LLM is actually evaluated by another LLM. And finally, it's like you iterate this process until you are satisfied. It's almost called as evaluation as a judge, where people started using different kinds of LLMs, like bigger models of LLMs, as a judges for the smaller models. And finally the agents, this is where it gets interesting. Until now you have seen that a lot of workflows and how to achieve like a regular task, like a complex subtask, and maybe a support agent take a task using a regular workflows itself or parallelization, everything. But here comes the actual agent, like when do you actually use an agent? And the first thing is that open-ended challenges, where you don't know the predefined set of path which needs to be taken for achieving the final solution. That's the first major important thing when you wanted to design an agent. And the second thing is that task demanding flexibility, where any task has a high range of flexibility. So it's not like you can say that this works for this task. Maybe the task does have like a n number of solutions, and llm can actually choose one of them which is needed according to them. And scenarios requiring autonomous decision making, where some kind of decisions might be interdependent on others, and llms can make that call autonomously without depending on you. and it might not have a lot of impact in overall like the project itself. And key consideration is that agents prioritize autonomy but comes with a higher cost and potential risk. This is the reason because imagine that you left your agent to modify all your files in your computer. It comes with a risk because even the first it takes a lot of time and cost to run these agents, but it also like comes with a risk because imagine there's a scenario where agent basically delete some of your source code file, etc., which is highly possible. So in such cases the risk factor is pretty high. And tool design is critical. Treat the agent computer interface with same attention and precision you would give a human interface. Like imagine that you gave a task to a human, the amount of like middle testing you do for agent, like a given a maybe a benchmarks or something which he needs to achieve overall to actually achieve the task, you need to look at agents in a very similar way. You cannot let them like go in a rogue mode and assuming that it will not cause any havoc at the end. And finally, they gave an example of agent, which is like a consumer agent where human asks a query about to the interface, and the interface is basically transfers it to the LLM, and the LLM basically asks either for classification or refinement if it is needed. If not, it will basically send that context to the environment to which the LLM agent does have access to, maybe searching files, writing paths, write code, testing code, and results, etc. And finally, it completes and displays it back to the simple. So the three core principles is that keep it simple, stay transparent, provide clear tool documentation. That is the whole goal of like building a agent versus workflow. And you need to have those 3 points checked for you to go to the agentic workflow itself. And final takeaway, which is a good statement, which I really liked, is that success isn't about complexity. It's about creating the right system for your needs. Start with simplicity, measure the outcomes, and scale up only when necessary. So, the final statement I really like is that you should only go to the agents only when it's needed and necessary for you. Not that you have agentic workflow and you should can just initiate a new agents everywhere. And another reason I really like this technical paper from research perspective is that there are a lot of agentic architectures out there, and every day new architecture is coming from Hugging Face or OpenAI or Microsoft or Google, etc. And it's very difficult to choose which architecture to use for your use case itself. So first you need to go through the goal, like do you actually need an agent? Then you can actually go and find out which architecture is good for you. Thank you everyone.